All right, hello everyone, and welcome again to Mr. Martin's Math. This is for BC Math 9, Chapter 4, Section 5, Dividing Polynomials by Monomials. All right, so by the end of this lesson, you should be able to use multiple strategies to divide a polynomial by a monomial, and then we're also going to be looking at solving problems involving division of polynomials and monomials. So we'll go through a couple examples of word problems and geometry problems that you might face for these types of questions. So let's start off with this first question here, this first scenario. So let's say you knew the area of a football field was 20x squared plus 24x, and the length of the football field was 4x. How would you find an expression for the width? So we know that the surface area of a rectangle is equal to length times width, okay? And if we were trying to figure out the width, we would want to divide both sides of the equation. We want to isolate this w, right? So we want to bring the length over to the other side, and so that we have an equation for width, which is equal to the surface area divided by the length. Okay? So in this situation then, my equation then with the surface area would be 20x squared plus 24x divided by my length, which is 4x. Okay? Which brings us to kind of the crux or the essence of this section, which is how do I divide a polynomial by a binomial? Okay? So if you remember back to last lesson, we learned how to multiply a polynomial by a monomial, right? So if I said 2x times x plus 5, I know that I have to distribute the monomial to each term in the polynomial, right? So it's essentially becomes 2x times x, and then plus 2x times 5, right? So the 2x gets applied to each term of the polynomial. All right, giving us a final answer of 2x squared plus 10x. All right, when dividing a polynomial by a monomial, you have to kind of do the same thing. You're distributing the monomial to each term in the polynomial. So what you essentially get is 20x squared divided by 4x plus 24x divided by 4x. So the x, that 4x, the denominator, needs to be applied to both terms in the numerator. Okay, both terms in your numerator need to be divided individually by the denominator. Okay, so essentially turns into this notation on the right here. Okay, and then from there, you're dividing monomials by monomials, and you should know how to do this from previous lesson 4.3, I think is when we looked at that. So from here, 20x squared divided by 4x, well, 20 divided by 4 is 5. X squared divided by x to the 1 is x to the 2 minus 1, which would just be x to the 1. So x, okay. And then this is going to be plus 24 divided by 4 is 6. And here the x's cancel out. And I get my final answer of 5x plus 6. 5x plus 6. And that would be the answer for this question. All right. Let's look at kind of, that's our approach today. That's what we're going to be doing, is distributing essentially the denominator, the monomial, to each term in the polynomial numerator. All right, so let's apply this a couple more times. I'm going to, change this into the distributed form first, and then do the division a couple times, show that extra middle step. However, we will be moving to towards not showing that middle step as we go along and get better at this. So first off, in my polynomial here, it's 2x squared divided by 6x squared divided by 2x. So 6x squared divided by 2x. All right, and then minus 8x divided by 2x. 8x divided by 2x. Okay, so again, each term in the numerator divided by the denominator individually. Okay, and then now I divide the monomials together. So 6 divided by 2 gives me 3. X squared divided by x gives me x. And then 8 divided by 2 gives me 4. And these x's cancel out, right? If you want to visualize that, x squared is really just 6 times x, and you're canceling out one of the x's on the top with the x on the bottom, and then you're just left with the x there. That's another way of visualizing that solution there. Okay, let's try another one together. 3x squared divided plus 6x divided by 3x. So again, I'm going to switch things over by distributing. 3x squared divided by 3x. 3x squared divided by 3x. And then that's plus 6x divided by 3x. Okay, again, each term in the polynomial numerator gets divided by our monomial denominator. Okay, I'm distributing essentially the denominator to each term of the numerator. And then 3 divided by 3 is 1. X squared divided by x just leaves me with x. And then 6 divided by 3 is 2. And then, the x's cancel out. Here the 3's cancel out. And the x in the denominator canceled out the squared, essentially. And you're left with 1x. So x plus 2. All right, similar situation. Even if they're long and scary, we're going to take the same approach here. Okay, now here I have to distribute my numerator to all 3 of the terms in the denominator. Okay, so if I were to rewrite this, again, you don't have to do this middle step if you can see it, right? If you can just see that, okay, it's this divided by my denominator, then this divided by my denominator, and then the last term divided by my denominator. You can do that without showing all the steps, without showing this middle step. But I want to be able to show it to you guys what the distribution looks like. So I have 14x cubed y divided by my denominator of 2xy, and then plus 18xy squared divided by 2xy, and then minus 26xy divided by 2xy. Okay, so again, I've distributed my denominator to each term in the numerator, and then I just divide these monomials. All right, 14 divided by 2 is 7. X cubed divided by x to the 1 is x squared, right? And remember, you subtract the exponents using those exponent laws, and then the y's just cancel out. So plus 18 divided by 2 is 9. X divided by x just canceled out, and y squared divided by y to the 1. I subtract the exponents, I get just y to the 1. And then lastly, minus 26 divided by 2 is 13. X cancel out, y cancel out, and I'm done. That is your final answer. Okay, so we're just distributing, but with division instead of multiplication. Your turn. All right, go ahead and pause this video, give these 3 a try, and then unpause the video, and we'll go over it together. Okay? All right, hopefully that went well for you. Here we go. All right, so here I'm going to switch these over. I got 15x squared divided by 3x, okay, and then minus 6x divided by 3x. All right, and then I just divide each monomial divisions here. So 15 divided by 3 is 5. X squared divided by x is x. Minus 6 divided by 3 is 2. And x divided by x cancels out. That's my final answer. Okay, this is how to kind of just do it in one step. You don't have to do this middle step that I've been doing here. You can just visualize it, right? So if I do 56a divided by 8a, That's going to give me 7a. 8 multiples of 8. 56 divided by 8 is 7. Got to trust myself. So 56 divided by 8 is 7, and a divided by a cancels itself out, and then I'm done for that one. Okay, and then minus 32 divided by 8 is 4, and then a cubed divided by a to the 1 is a squared. All right, and then that's how you do it, just without showing that middle step. Okay, you just have to make sure that mentally you know that the denominator needs to apply to all the terms in the numerator when you're dividing polynomials by monomials. Okay, that's the case even if you were to divide a polynomial by a polynomial, but we're not doing that in this chapter. One last one here. I have 2.3 f squared g divided by 1.3 fg. All right, so 2.3 divided by 1.3 gives me, wonder here if I can turn this into a fraction. Math, fraction, 23 over 13. If I get rid of the decimal, yeah, okay. I'll use the decimal. They're using decimals here, so we can use approximates as well. So one decimal place is going to be give me 1.8. F squared divided by f is f, and g divided by g, cancels out, and then that's it for the first two terms. And then it's going to be minus this second term here. So 8.2 divided by 1.3, 8.2 divided by 1.3 is approximately 6.3. The f's cancel out, and then g squared divided by g is g. Okay. Now when I'm canceling out the g on this first term and the f on the second term, I don't cancel it out on the bottom like when I'm writing it out, because I need to make sure that these f's and g's are not canceled out for the other term that I have to divide. Okay, but they are canceled out in my final answer. Okay, just a note on that. All right. How do we visualize this with algebra tiles? Okay. So here when you're dealing with algebra tiles, okay, it's just like we were dealing before. You have to draw your tiles, and you have to make sure that your tiles are drawn in some kind of rectangular shape. Okay. So here if I have 4x squared, so it's 4x squared tiles. 1, 2, 3, 4. Okay, and you also want it to match one of your sides here. So if this side is 2x, okay, all my tiles have to kind of fit along with the same length as those 2x tiles. Okay, now of course these are shaded in here, but that length has to be seen across. So my negative 6x's, I'm going to put behind here, and I'm going to split them 3 and 3. I'm going to split them into two groups so that the two groups have the same length. Okay? So, I shouldn't have done that in that order. See if I can erase just the arrows. Awesome. So that gives me positive 4x squared. So I need to shade those in. Let me just use my cheater approach here. Shading in with my highlighter. All right. And so now when it comes to determining the my result here is going to go in this space here, okay, based on the width of these tiles in this arrangement. Okay, the length is set by these two tiles, all right, left to right for all of the tiles in the middle of the matrix. But now the width is going to set the tiles for the top. So the width of my first couple tiles is a full x length. Okay, And because they're positive and the 2x is positive, these are going to be positive as well. All right. And the width of those 6x tiles is the width of just 1. And because they're negative, those are going to be negative as well. So this gives me a solution of 2x minus 3. Okay? And if you were to do this algebraically, if I were to just quickly set this up, x squared minus 6x divided by 2x, 4x squared divided by 2x is 2x, and then minus 6x divided by 2x, so 6 divided by 2 is 3, x divided by x cancels out. I get the same answer as I got with my algebra tiles. Okay? Now let's apply this to a couple more examples here. So examples to solve the surface area problem by dividing a polynomial by a monomial. Okay, so here they're asking us, what is the ratio of the surface area of the radius, what is the ratio of the surface area to the radius of the cylinder? Write the ratio in simplified form. Okay, so when it comes to finding the surface area of a cylinder, you need to solve for the area on top, this part here, right? The area on the bottom, and then the area all the way around, okay, on the outside of the cylinder, okay? And you can roll out a cylinder. If you were to roll out a cylinder, it would look like this. Okay, this being the side part, and then this being the top and bottom surface areas. Okay, and we have to add these components all together. So for the surface area of the top, my equation is pi r squared, right? That's how to find the surface area of a circle. So I have pi r squared, and I have 2 of these, right? So I can say that it's 2 pi r squared, all right? And then plus the surface area of this rectangle here. Now the height of the rectangle here is just h, okay? But the length of this rectangle here is the circumference of the circle on the top and bottom, right? And the circumference of that circle is 2 pi r. So I end up with 2 pi r, which is the circumference of the top and bottom circles of a cylinder, times the height h would give me the area of the cylinder. Okay? And I want the ratio of the surface area to the radius of the cylinder. So I'm going to divide this expression by r. Okay? So again, dividing polynomial on the top by a monomial, 2 pi r squared divided by r gives me 2 pi r, right? And then plus 2 pi rh gives me 2 pi h. The r's cancel out. Okay, that would be your final answer. Now here for B, if the height h of the cylinder is the same as the radius, what is the ratio of surface area to radius? Write the answer in simplified form. So in this situation, what they're saying is if this is 2 pi r squared, nothing changes there. But let's say r and h are equal to each other. Okay, so I can substitute r for the h. So this would be 2 pi r, and instead of putting h, I put another r. Okay, divided by r, I'm still going to get 2 pi r plus 2 pi r, right? Because now one of the r's is going to get, gives me this gives me this, okay? Now here, notice that these are like terms, so I can add these together. Okay, these are like terms. So I can add the coefficients of the like terms because they both have pi and they both have r. So 2 plus 2 would give me 4 pi r as my final answer. Okay, so they just wanted you to set up like terms and be able to simplify that extra step for that problem. Example 4, solve the volume problem by dividing a polynomial by a monomial. Okay, so here we have a rectangular fish tank that has a volume of 7.5 w squared minus 3w. If the length is 0.6 meters and the width is w, what is the height of the tank? Okay. Now I'm going to ask you guys actually to pause in a second here this question and try it on your own. But I'm just going to give you the equation just to remember. Remember, for volume of a tank, it's equal to length times width times height. Okay? And in order to, so with that in mind, go ahead and pause this question and see if you can solve for the height of the tank, given that length is 0.6 and width is w. Okay, they're not asking for a numerical number. They're just asking for the expression that represents the height of the tank. So go ahead and pause, and we'll come back together and confirm our answers together. All right, hopefully you were able to get through that. So let's take a look here. So in order to solve for height, if its volume is equal to length, width, height, and I want to solve for height, I need to divide both sides by length times width, right? So that I get h by itself. So I get volume is equal, divided by length times width is equal to height. Okay, so that's what I want to set up for my problem here. I know that the volume is 7.5 w squared minus 3w. And length times width, my length is 0.6, my width is w. So length times width would just be 0.6 w. Okay? And I know that then this is equal to height. So if I can divide my volume by my length times width, I will get my height. And so, I've set up a question hopefully similar or familiar to the ones we've been solving this set of notes. 7.5 w squared divided by 0.6 w. So 7.5 divided by 0.6 gives me 12.5 w. Okay, that's what gives me this. And then it's minus 3w divided by 0.6 w. 3 divided by 0.6 gives me 5 minus 5, and the w's cancel out. And that would be my final answer. Okay, minus all the colors. Okay, this would be equal to my height. Okay, so hopefully this set of notes was clear and understandable to you guys. If there's something that you need to go back and review, it's a YouTube video, so go ahead and replay it. Scroll through, fast forward, rewind, play it 1.5 speed if you want. You can do that. Whatever you need to do to help yourselves be successful. Quick checkup here. We had set goals at the beginning of this lesson to be able to use multiple strategies to divide a polynomial by a binomial. The two strategies were using just regular algebra and also the algebra tiles. And then being able to solve problems, specifically a lot of these geometry problems, that involve division of polynomials by binomials. Hopefully you're getting more comfortable with that. If you're in my class at this point, you should be working on this assignment here from your textbooks, section 4.5, which is the last section of this chapter. So expect the test to come up shortly. And until next time, stay